Another lesson, another day. All right, so today we are going to be dealing with the side splitter theorem, okay? Side splitter theorem. And basically, I call it the SST theorem, or the SST, whatever. Okay, so what does it say? It says that if a line is parallel, okay, to a side of a triangle and intersects the two other sides, then this line divides those two sides proportionally. What the hell does that mean? Easy. Put it this way. How many triangles do you see here? The small one and the big one. That's all you need to know. So then these will be divided proportionally. I'm going to explain to you. So let's do the small triangle first. That is the small triangle, and the name of the small triangle is WVX, right? Okay, better? Yes. Okay. I'm tired of saying okay. So WVX. And now we draw the larger triangle. Something like that, right? Now the name of this triangle is YVZ. YVZ. Now look at this. I'm supposed to solve this problem. I'm supposed to find the missing measure, which is VX. So let's label the sides. VW is 7. WY is 14. VX is I have no idea. And XZ is 16. So this line, look, is parallel to this other line right here. So that means that it divides this, okay, the sides proportionally. Meaning that this little triangle is proportional to this one. Meaning that they have the same shape, okay, not the same size. So they're similar. So what I gotta do is I need to find the scale ratio, okay? The scale, let me see, scale, yeah, scale factor, scale ratio, whatever. All right, so how am I gonna do this? Easy, form a proportion. Now that we have separated the two triangles, we know that this is 7, okay? I don't know what this is. I know that this right here, VY is what? What is VY? VY is 21. 7 plus 14 is 21. And I know that VZ is what? VZ is, let's call this, what do you want to call this? You want to call it X? Okay, let's call it X. So VZ is 16 plus X. That's what you know. So with that information, remember the sum of these two sides, 16 plus this side is 16 plus X. They're not like terms, so you don't add them up together. Okay, so let's set up our proportion. Okay, how do I do this? Easy. You are going to put corresponding sides as a ratio. So 7 is to 21 as, we call this X, right? As X is to 16 plus X. See that? That's how you set up the proportion. So then let's solve it. So we're gonna cross multiply, correct? Okay, when we cross multiply, then we have to use the distributive property here. 7 times 16 plus X. So first let's find out what is 7 times 16. 7 times 16 is, okay, so I'm gonna put it right here, 112. And 7 times X is 7X. Equals, and now 21 times X is 21X. See that? Okay then. So now let's solve for X. So I subtract 7X from both sides, so I get 14X equaling 112. Then I'm gonna divide 112 by 14, and I'm gonna get X equaling 8. So therefore, VX is 8. See that? Nice, right? Of course, sometimes it's obvious to see it. And what am I saying? What am I saying? Easy. If this is 7 and this is 14, 7 is half of 14. So then this one should be half of 16, so this one should be 8. But anyway, this is how you do it. Now let's do a problem, because I want to show you something, and I don't like to explain it in different ways sometimes because it confuses people, but I am going to do it anyways. Alright, let's do this problem. So CB is 3, CB is 3, CA is 10, all this is 10. That makes this 7. Right. Okay, CE is 6. What is the length of ET? ET, I don't know. I'm going to call it X. So, I am going to do this problem in 2 different ways. The first way, which is looking at how many triangles I have, because that's the way I want you to do it forever. But those of you who can actually understand the other method, then by all means use it. So I am going to compare the small triangle to the big triangle. So I will divide this. I could draw 2 little triangles, 2 triangles right here with the measures, which is basically what I should do. They're not going to be drawn to scale, okay? This is just for information purposes. See now? Oh, okay, that's better. So this one is going to be, okay, this is a small triangle, so I'm talking about BCE. BCE. And then the big triangle is ACT. ACT. See it? Okay, now let's label the measures. So BC is 3. CA is 10. Okay, CE is 6. I don't know what CT is. So CT should be 6 plus X. See that? Okay then. Now that I have the information, I'm going to set up my proportion. So remember, always compare corresponding sides. Okay? So 3 is to 6. 3 is, no, not to 6, sorry. 3 is to 10. Oh my God, what the hell are you thinking? Okay, 3 is to 10 as, so equal sign, 6 is to 6 plus X. Okay, now I cross multiply. So 3 times 6 is 18. 3 times X is 3X. The equal sign. 10 times 6 is 60. Okay, now I solve for X. So then I'm going to subtract 18 from both sides. So I get 3X equals 60 minus 18 is 42. Now I divide by 3. What is 42 divided by 3? 14. Okay? So X is 14. So ET is 14. So correct choice is choice number 2. Okay, people. Now I'm going to show you the other method. But this other method only works when the lengths are outside, on the sides right here, not inside. Not inside, okay? Just on the outside. On the outside, all you gotta do is compare the same side, like 3 over 7 equals 6 over X. You see that? So let's multiply. 7 times 6, okay, X times 3 is 3X. 7 times 6 is 42. Okay, you see that? Which is the same thing I have here after I did all that. So I'm not even gonna solve over here, but you already know what X is. So this method only works when the measures are on the outside, not on the inside. So please keep that in mind. That's why I said, just use the regular method. Okay, so let us move on to the next problem. So I have AT is 5, TB is 7, AV is 10. They want to know the length of BC. Alright, so let's see if you understood what I just said. The lengths are on the outside, so I can use the shortcut method. So I'm going to compare 5 to 7 and 10 2x. See that? And now you cross multiply and solve for x. (5x) equals to 70. Okay? And now I am going to divide by 5. So 70 divided by 5 is 14. So the measure of VC is 14. Right here. See that? Not bad, right? Now remember, the other method will always give you the right answer. This one only when the lengths are on the outside. Okay, let's see this one right here. So the line, this BC is parallel to ED. That's what it says on the problem. Now AC is x minus 3. Okay. BE is 20. AB is 16. AD is 2x plus 2. Okay? So once again, the measures are on the outside. So it's cool. That means that we could just compare, you know, the one segment to the other, one segment to the other. So 16 is to 20 as x minus 3 is to 2x plus 2. And then just cross multiply. So when you cross multiply, you get, well, let's see now. 16 times 2x is 32x. Plus 16 times 12 is, I have no idea, 192. So that's this cross multiplication. Now let's do this one. 20 times x is 20x. 20 times negative 3 is negative 60. And now I solve for x. So what am I going to do? Well, I got variables on both sides, so I'm going to get rid of the lesser one. So I'm going to subtract 20 from both 20x from both sides. So I get 12x, okay, plus 192 equals 60, negative 60, sorry. And now I am going to subtract 192 from both sides. Okay? And something is not right over here. Where do I get negative 60? X minus 3. So then 192, where do I get 192? 20 times, let me 16. Whoa, major problem. This is not 16 times 12, this is 16 times 2. Oh my God, thank God. Now I get it. So this is plus 32. Right? Okay. 16 times 2 is 32. Okay, now 20. The length of BE is 20. All right. Something is not right over here. X, is this x plus 2? Let me see now. I think that we have a problem here. This looks like a plus, but if this is a plus, I'm gonna end up with something weird right here, which I don't want to. I think this is 2x minus 2. I'm just gonna give the benefit of the doubt. Okay, so this is minus 2. This is a minus 2. And you'll understand why I'm saying that this is a minus 2, although it looks like a plus. So then 16 times negative 2 is negative 32. Even there, I'm going crazy. No, it looks like a plus. It looks like a plus. 12x, 32x. Oh my God. No, 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 and no. Okay, I'm gonna have to erase the whole thing. 16 is to 20 as x minus 3 is to 2x plus this. So 16, Oh my God, I'm confused. I'm confused, but why am I confused? Something is not right over here. And I don't like to be confused, because then I go crazy. I'm really gonna go crazy. What the hell? Let me see. This has to be 2x plus 2. It looks like a 2x plus 2. Oh my God. But then, when I multiply, 16 times 2 is 32x. 16 times negative 2, no, it's negative 32. Okay. 20. I compare the segments. What is wrong with me? AD is 2x plus 2. You know what? I'm gonna go through the problem and see what is it that I'm doing wrong. Okay. 32. 16 times 2 is 32. 32, right? Yes. Then this is 20x. 20 times negative 3 is negative 60. I have a problem. Why do I have that problem? Because, let me see. Okay, in the diagram below, triangle B is a point on AB. Okay, and C is a point on AD such that AC is x minus 3. AC is x minus 3. BE is 20. AB is 16. AD, oh my God, oh my God, I found it. AD is 2x plus 2. The whole thing is 2x plus 2. No wonder. So now, what is CD? I don't know. So then, you know what? Easy. Well, actually, I can figure it out. I can find CD. How? And I'm gonna have to show you how to do it on a different piece of paper. All right. So CD plus AC is 2x plus 2. Therefore, AD minus AC should be CD. Okay, this whole thing minus this part is this part. So 2x plus 2, okay, minus x minus 3, okay, should give me this part right here. So let's see. 2 minus negative 3 is 5. 2x minus x is x. So x plus 5. So this right here is x plus 5. Now we could talk. And I am not going to edit anything out. So let me see. 16 over 20 is good. And then x minus 3 over x plus 5. I hope you understood my mistake, because we all learn from our mistakes. So x minus 3 over x plus 5. Okay? So let's see now. Let's multiply now. So 16 times x is 16x. Now 16 times 5 is 80. Okay? And now, the equal sign. 20 times x is 20x. 20 times negative 3 is negative 60. Okay, now we're talking. So we get rid of the lesser one. So we're going to subtract 16 from both sides. So I'm going to get 80 equals to 4x minus 60. And now I am going to add 60 to both sides. So I get 4x equals, well, what is 80 plus 60? 140, right? Okay, so we got 4x equals 140. And now we're going to divide by 4. So x becomes 35. Now let's answer the question. I want to know the length of AC. This one right here, AC. Well, if x is 35, then 35 minus 3 should be 32. So AC equals 32. And bada bing bada boom, this thing is over. Now I want to do it the the regular method. Remember the method that I taught you first? So that's exactly what I'm gonna do right now. I know it's gonna take a little longer, but it's nice that we know how to do it. Okay, so these are the two triangles that I see here. This one is BAC, and this one is EAD. Okay, and what do I know about them? I know that the length of AB is 16. Now the length of EA is actually 36, because it's the whole thing here. The length of AC is x minus 3. And I know that the whole length of AD is 2x plus 2. Makes sense? So now, since I have the two triangles, all I have to do is compare corresponding sides. So I'm going to make my proportion. 16 over 36, okay, is to x minus 3 over 2x plus 2. Now we're going to cross multiply. And now you'll see what's going on. So 16 times 2x is 32x. 16 times 2 is 32. Now 36 times x is 36x. And 36 times 3, it's 108. So this is minus 108 because it's negative. And now I solve this equation. So I'm going to subtract, I have variables on both sides, so I'm going to subtract 32x from both sides. So I get 32, this one, equals, well, 36x minus 32x is 4x. Minus 108. And now I'm going to add 108 to both sides. So I get 140 equals to 4x. Then I divide by 4. And I get x equals 35. See that? Same thing. I like this method better because there is no room for error. Now, although my mistake was that I thought that this little piece was 2x plus 2. I didn't read it, that it said that the whole AD was 2x plus 2. Okay? So now you got it. All right. So let's see now. In the diagram below, okay, we have AE is 3. AE is 3. ED is 6. ED is 6. This time I'm going to be very careful. DC is 15. DC is 15. They want me to find the length of BE. I'm going to tell you right now, there is no way around this. We cannot use the shortcut because the lengths that they gave us are not on the outside of the parallel lines. You see that? One of the measures is on the inside, and they are asking me for the other one that is on the inside. Therefore, I have to use the method of the two triangles. The only thing is that right now, I'm not going to separate the two triangles. You are going to separate them, or you are going to visualize them. All right? So, for example, one of the triangles is EAB. The other triangle is DAC. Got it? Okay. So let's set up our proportions, comparing sides to sides, not segments to segments, sides to side. So AE is 3. This side of this triangle is going to be compared to this side of the other triangle. So the other triangle, okay, is AD. AD measures 9. See that? Now I compare the shortest side, okay, with the longest side. So I gotta compare the shortest side, which I don't know, I'm gonna call it X, to the longest side, which is 15. So does it make sense? Well, it has to make sense. All I did was have the two triangles right here. Okay, separate them. All right, so 15 times 3 is 45. I'm not going to multiply 9 times x because then I'll be moving the 9 over here. And really, I don't need the 9 over here because then I'm going to have to divide by 9 again. So let's just leave it like that. See that? All I did was multiply here and then I left the x alone automatically. Now 45 divided by 9. What is 45 divided by 9? 9 times 5 is 45, so x is 5. So then this one is 5 right here. Beautiful, right? All right, let's move on. So I have in triangle ABC here, I don't have a visual, and guess what? It's nice that you draw a visual. So any triangle will suffice. Okay, any triangle will suffice. You just need a visual. Okay, so let's see now. In triangle ABC, point D is on AB. So AB, point D is on AB, so this is point D. And point E is on BC. So now I know how to label my triangle. And then DE, DE. Okay? DE is parallel to AC. That's what it says here. So DB is 2. DA is 7. And DE is 3. DE is 3. Again, the measure is inside the triangle. Therefore, I cannot use the shortcut. So I'm going to have to separate the triangles. Okay? They want to know what the length of AC is. They want to know this length right here. Not a problem. So let's see now. Two triangles. You see that? DBE and ABC. Two triangles. The small one and the large one. So let's set up our proportion. Remember, two triangles, therefore we have to compare corresponding sides. So DB corresponds to AB. 7 plus 2 is 9. The whole AB is 9. Okay? If you don't understand, then go back to when I separated the two triangles. Alright? Alright. Now, I'm comparing the small to the large. So then I compare the small to the large. So 3 is 2x, right? Now I cross multiply, so I get 27 equals to 2x, or 2x equals 27. Anyways, I divide by 2 and I get x being 13.5. Question is, what is AC? Well, AC is x and x is 13.5, so I found my answer. Okay. Here we go again. In the diagram below, at least we have the diagram. So this problem you're gonna do on your own. Okay? Read it and see if maybe you've seen it somewhere. Okay? And now let us do this problem. So again, side splitter theorem. If the two segments, the two lines are parallel, then it forms two triangles that are proportional to each other. So let's see. CE is 25. Okay. AD is 18. AD is 18. DB is 12. DB is 12. I need to find EB. Okay, I could use the shortcut here. Look, this one right here, this one right here, the measures are on the outside, so I can use the shortcut. So what do I do? Easy, compare segments to segments. So x is to 25 as 12 is to 18. You cross multiply and you find x, and that's it. Okay, now this question, what does the side splitter theorem states? Well, you have it right here. It states that if a line is parallel to a side of a triangle and intersects the two other sides, then this line divides those two sides proportionally. Got it? Alright, good. Alright, see you on the next lesson. Bye bye.